Welcome back to BAS 120. Now we're on chapter 5, example 18. We're going to talk about expected value. So expected value refers to the value of a random variable one would expect to find if one could repeat the random variable process an infinite number of times and take the average of the values. So if I rolled a dice an infinite number of times, I would expect to get a 2 1/36 of the time. So this just says I take up the value of 2 times the probability and sum those up. This will become a little more clear as we do a couple examples. So let's do example number 1. Let's say we roll a pair of dice 36 times. We would have an expected value. We would expect to get a 7. Well, we're rolling the dice X times, 36 times. On any given individual one attempt, the probability of getting a 6 is 6 over 36. So if we rolled the dice 36 times, we would expect to get 6 sevens, meaning that we would expect to get 6 totals of 7 when we rolled the dice 36 times. We rolled it 36 times. The probability of any one occurrence of a 7 coming up is 6 over 36. So the expected number or the expected value of 7s that we would get if we rolled the dice 36 times is 6. Let's say we rolled a pair of dice 4 times. What is the expected value? Did we get a 4? How many 4s do we think we'll get if we roll the dice 4 times? Well, we're rolling the dice 4. The probability of any one roll of getting a 4 is 3 out of 36. So 4 times 3 out of 36 is 12/36 or 1/3. Let's go to 5 not 9 and talk about some of the things. Hopefully, if you haven't seen it, you can download this game. Links at the bottom of this. But there's a popular game show called Deal, No Deal, where they select, I think they start with 26 cases. And there's varying dollar amounts from a penny up to $1 million of cases. And each step, with each step, you reveal so many cases and they come off the board. So in this example, I've already taken out 11 cases, and what's left is the ones that are highlighted here. Now the way the game works is at a certain point, the bank will offer you a certain amount of money and you have the chance to continue to play to see what's in case number 21. Now, case 21 is one of these highlighted dollar values, so it could be $1 million. I could win $1 million. But the bank is saying they will pay me $33,000 to quit the game right now, take the deal, take the $33,000, or I can say no deal, I want to continue to play. Well, this whole game and this whole bank is based on an expected value. So let's see what my expected value is of my case 21. We don't know what case 21 is, but we know there's 15 cases left. So there's a 1 in 15 chance of my case 21 being any one of these numbers. So there's a 1 in 15 chance of it being a penny, a 1 in 15 chance of it being $1, all the way down to a 1 in 15 chance of it being the $1 million. What I've done is I've taken the expected value of each one of these. By, of course, our formula is just multiplying the value times the probability, and I sum those up, right? Sum up my expected values of each one, because remember, that's our equation, to take the sum of all of these, right? Now, I've taken the sum of all of them, and it comes out to $111,087. That is the expected value of my case 21. Now, of course, case 21 can't be exactly $101,000 because there is no case that's $111,000. But that is the expected value. So what it allows me to do is compare it to this, what the bank is offering. The bank's only offering $33,000. So at this point, I think a lot of folks would say, well, I think I'm going to reject that bank offer because my expected value is $111,000 and the bank's only offering $33,000. So I'm going to reject that offer and play on in the game. Well, I revealed 4 more cases, and unfortunately, I'm not very lucky because you can see a lot of the high dollar ones went away, $1 million, et cetera, et cetera, et cetera. So, not surprisingly, the offer of the bank went way down because we're going to see in a minute the expected value is going to go way down. Because now we're down to, I took out 4, now we're down to just 11 cases. So there's a 1 in 11 probability of any one of these events, and those are the cases that are left. So if I sum this up, I get an expected value of $15,115. The offer was $11,000. I went on and played the game. My case ended up being the $10,000. Here's a link. You can play the game. If you haven't played it, it's very, very interesting. In fact, you can sit there and do what I did right here. Calculate your expected value to see how good an offer the bank is going to make. Now, as you get fewer and fewer cases, these numbers are going to start becoming closer and closer together because what's happening, there's less and less doubt. You can almost, when you get down to 2 cases, the expected value becomes pretty obvious. So that's expected value. Let's do one last one on expected value. Let's do an expected value of a raffle. This is example 5 too. Let's say there's a raffle prize of $25,000, and they sold 1,000 tickets, and the cost of the ticket is $50. So I got to pay $50 to play the game. I can win $25,000, and there's 1,000 tickets sold. So let's see what my expected value is. So there's 2 outcomes, right? I could lose, not have the winning ticket, and if I don't have the winning ticket, I'm out my $50, right? If I do have the winning ticket, I have income of, well, not the whole $25,000 because I had to pay $50 for the ticket, so it's $24,950. Now, what's the probability that I lose? Well, there's only one winning ticket, so the probability that I lose, first I did the probability that I win is 1 in 1,000. So the probability that I don't win is 1 minus the probability that I do win. Or you could have said there's 999 losing tickets divided by 1. You would get the same thing. But I wanted to show you one of the rules, that both of these have to add up to 1. So my expected value is just what we would think. It's my $50 or negative $50 times the probability of that event, which is very, very high for any of you that have played Raffles. You usually don't win. But then here's my expected value of if I do win. 1 in 1,000 chance. I win $24,950. Then I sum these all up to get my... and my expected value is I'm going to lose, I guess I've rounded here a little bit, I'm going to lose there we go. I'm going to lose exactly $25. A little bit around there, right? Probability that I've taken the expected value and summed them all up. So most likely I'm going to spend $50. I expect every time I play. So this means if I played the lottery or the raffle an infinite number of times, I would lose $25 on each one I played. That would be the expected value. And this is, what Las Vegas and the whole gaming industry is based on. So that covered expected value. Any questions, let me know.